A very good morning to one and all. This is Che Anusha, working as lecturer in physics under the Department of Technical Education, Telangana, and I'm working at SS Government Polytechnic, Zahirabad, and I'm working in general section. The subject I'm dealing with is applied physics, that is for first year, second sem students, and the subject code is 18 common 103F. This is about myself, and the topic what we are going to discuss here is electricity and measuring instruments, that is fifth chapter from our syllabus. Now in today's session we are going to learn about Kirchhoff laws and their explanation. Now to learn this we'll take a help of a small PowerPoint presentation here. Let us move on to our session now. The main objective of our session is, on completion of this period, you will be able to understand what are Kirchhoff laws and what is the importance of Kirchhoff laws. There are two laws, Kirchhoff's first law and second law. Let us learn about these laws. Now let us recall or recap what we learned in the previous session. In the previous session, we learned about the resistance in a circuit when resistors are connected in series and parallel. Now, in the previous sessions, we learned about Ohm's law, where we got an expression or we got a relation between potential difference and current. Now, by using that, we can find what is the resistance in the circuit. If the electrical circuit is to be studied only, Ohm's law is not enough to understand or by using only Ohm's law we cannot measure the amount of current which is passing in the circuit, or we cannot measure the potential difference which is present in the electrical circuit. Now to find the amount of current and potential difference in electrical networks, Kirchhoff defined laws which are known as Kirchhoff laws. See, to solve problem in complicated network, we use Kirchhoff laws. Now for studying current which is flowing through a network, we use Kirchhoff's first law. It defines the way that electric current is distributed while crossing a junction. Now let us see what are Kirchhoff laws. Now here is Kirchhoff's first law, which is also known as junction law or current law, because here we are going to see the relation between the currents which are passing at a junction. Now according to Kirchhoff's first law, algebraic sum of currents meeting at any junction is 0, or we can state it as sum of currents which are flowing towards junction, they are equal to sum of currents which are flowing out of the junction. Now here, to understand this law, let us consider a junction. Now junction is nothing but, now generally what is junction? We use junction which is related to the place where many roads meet, and also we can say a place where many routes join. We call that as a junction. Now in electrical networks also we can see a junction which is nothing but simply a point from that at that point many currents meet. So the point at which many currents meet in an electric circuit is junction. Now, according to Kirchhoff's first law, the algebraic sum of currents meeting at a junction is equals to 0. Now, to understand or to explain what is Kirchhoff's first law, here in the picture we are considering a junction. You can see a junction where 5 currents are meeting: I1, I2, I3, I4 and I5. Now you can see, to understand it easily, I have used arrows which are in pink color in the picture. Now you can see the directions of current flowing. Now generally at junction, currents may okay, I'm not talking about electric junction. Generally at junctions, what I said, junction is nothing but that is a place where many roads meet. Now at this junction, always vehicles or the persons who are moving, they won't move towards the junction or they won't move away from the junction. Some may move towards the junction and some may move away from the junction. Similarly, here we are considering currents. Now here you can see I1, I2 and I3. They are flowing towards the junction, and I4 and I5 are flowing away from the junction. Now, let the currents I1 and I2 towards the junction, I4 and I5 are flowing away from the junction. Now, currents flowing towards junction are taken as positive. This is the very, 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 very important sign convention we need to remember, that currents flowing towards junction are considered as positive and currents flowing away from the junction are taken as negative. So according to Kirchhoff's first law, which is known as current law, now as I1, I2 and I3 are flowing towards the junction, they are taken as positive. So I1 plus I2 plus I3 plus of minus I4 plus of minus I5 is equal to 0. Now plus of minus, we consider it as directly as minus I4 and minus I5. So this is according to Kirchhoff's first law. Now if we bring the negative terms to other side of the equation, the equation is now it is I1 plus I2 plus I3 is equals to I4 plus I5. Now what are I1, I2 and I3? They are the currents which are flowing towards the junction. So they are known as incoming currents. And what are I4 and I5? They are the currents which are flowing away from the junction. So they are known as outgoing currents. So finally, we got that sum of incoming currents at a junction is equals to sum of outgoing currents at the same point, that is at that junction. So this is what the alternative statement for Kirchhoff's first law. Very, very, very important expression. So the first law is also called as law of conservation of electric charge. Now, what is Kirchhoff's second law, or which is known as voltage law? Because in this law we are going to see the relation between voltage and loop. Now here we are using a term loop. Loop is nothing but a closed circuit is known as loop. So algebraic sum of product of currents and resistance is simply potential difference. So the algebraic sum of potential differences in any closed mesh or loop is equal to algebraic sum of EMF in the same loop. So in any closed circuit, in any closed electric circuit, we have EMF and we have potential difference, which is simply product of current and resistance. So the sum of product of currents and resistance is equal to sum of EMFs in the same loop. Or else we can say, in any closed circuit or in any closed loop, the algebraic sum of the potential difference is equal to 0. Now, here also a very important point is we need sign convention. The product of currents and resistance in the direction of the flow of currents are taken as positive. Nothing but the potential difference is considered as positive when they are in the direction of flow of current. And the EMF is taken as negative when it is from negative pole to positive pole of the battery, when its direction is from negative pole to positive pole of the battery. Now, to understand this, let us consider a closed loop here. You can see here a closed loop A, B, C, D, E, F, G. Okay, I took a battery as E. So as it is E, I missed E in the loop name. That is, now the loop is A, B, C, D, F, G and A, so that it is completely closed. You can see two EMFs. We can take them as E1 and E2. I missed it. Now you can see there are four resistors, R1, R2, R3 and R4. Now as the current is flowing from battery, that is I, when it is passing from resistor R1, the current we consider it as I1, and when it is passing from, or when it is I, when it is traveling in another path, that is from A to B, here the current we consider it as I2. I1 and I2 meet at D and they form as I, and they again move towards battery. Now here R1, R2, R3 and R4 are the resistances, and small r is internal resistance of each EMF. We can neglect it because we are considering that potential difference as E. Now applying Kirchhoff's second law to the closed mesh ABCDA. So what is the mesh ABCDA? Let me show you. This is the mesh. So in this we are having I2, R3, R4, R2 and R1 and also I1. So using sign convention, I1 R1 plus I1 R2 minus I2 R4 minus I2 R3 is equal to 0. I think I missed 0 here. And why I2 R4 and I2 R3 are minus? Because the current flow is opposite to the direction of loop direction. Now applying Kirchhoff's second law to the closed mesh GADFG, there we are having E1 and E2. So I1 R1 plus I1 R2 plus IR plus IR, that is the potential difference across the batteries, so is equals to E plus E, E1 plus E2. Now this Kirchhoff's second law is also called law of conservation of energy. That is nothing but the amount of potential difference we are giving to the circuit using battery, that is equally distributed among all the resistors, and the energy is conserved in the closed loop. Now what is the importance of these Kirchhoff laws? Now we can use these Kirchhoff laws to calculate what is the current in the electric circuit and what is effective resistance, and also we can calculate what is the potential difference in a complicated networks. So what we learned in this session, let us summarize. We have discussed or learned about Kirchhoff's junction law, which is also known as Kirchhoff's first law, and Kirchhoff's second law, which is also known as loop law or voltage law. And also we have seen what is the importance of Kirchhoff law. Now let us see how much we learned in this session. The sum of currents meeting at a junction is sum of magnitudes of current, sum of incoming current, sum is equal to 0, none of the above. So this is what Kirchhoff's first law is stating, that is sum of currents meeting at junction is equal to 0. And Kirchhoff's first law states that algebraic sum of currents in a circuit is 0, voltages and currents is 0, voltage is 0, none of the above. Currents in a circuit is 0. Now here you can see 5 conductors are joined and they are having 5 ampere, 10 ampere and 15 ampere currents which are flowing towards the junction through 3 conductors. Now 20 ampere is going out through one conductor. Flow of current in another conductor is 5 ampere, 10 ampere, 0 ampere and 20 ampere. It is 10 ampere. Let us see that towards or 15 plus 10 plus 5, that is 30. So 30 equals to 20 plus flow of current in another conductor. So 30 minus 20 is 10 ampere. Now here are some frequently asked questions. State Kirchhoff laws. So you need to state both the laws and state and explain Kirchhoff junction law. With neat diagram, state and explain Kirchhoff's second law. So with this we are concluding our session. I hope this is very useful for you and you understood it. Thank you so much for listening it carefully. Thank you.